Hi everyone, I am Geetha, Assistant Professor, Department of Mathematics, SNS College of Engineering. In this session, we are going to discuss about Markov process. A Markov process is a stochastic model that undergoes transition from one state to another using a set of probabilities. It is memoryless and relies only on the current state. For example, weather patterns can be modeled using Markov process to predict future conditions. Definition and concept of Markov process. A Markov process named after mathematician Andrei Markov is a stochastic model that undergoes transitions from one state to another. It is a memoryless, meaning the probability of transitioning to the next state depends only on the current state, not the previous history. This concept is widely used in various fields such as finance, biology, and weather forecasting. Understanding state and transition probability. A state in Markov process, which represents a particular situation or condition at the given time. Transition probabilities, likelihood of moving from one state to another in the next step. Matrix representation, states as rows and transition probabilities as columns in a matrix. Markov property and memorylessness. The Markov property states that the future state of a system depends only on the current state, not on the past. This leads to the concept of memorylessness, where future transitions are independent of the path that lead to the current state. Types of Markov process. Discrete time Markov chain, a stochastic process with discrete state space and time steps. Continuous time Markov chain, a stochastic process with continuous time and state space. Markov decision process, a mathematical framework for modeling decision making. Discrete time Markov chain. A discrete time Markov chain is a mathematical system that undergoes the transition from one state to another in a sequence of discrete time steps. Each transition depends only on the current state and not on the previous history. In continuous time Markov chain transition probabilities, each transition probabilities represent a probability of moving to a different state. Continuous transition. A transition occurs continuously without discrete time intervals. Stochastic process. It is a stochastic process where the next state depends only on the current state. Markov decision process. Defining the problem first. Identifying the decision points and possible actions. Second step, transition probabilities. Evaluating the likelihood of moving between states. Third step, optimal policy determination. Establishing the best course of action at each decision point. And next one is reward assignment. Assigning values to the outcome to guide decision making. So, Markov decision process involves defining the problem, considering the transition probability, determining the optimal policies and assigning rewards. It aids in making decisions based on the states and actions, finding the best strategies for real life scenarios. Applications of Markov process in real life. Finance. Markov process are used in stock market analysis and modeling of financial trend. Manufacturing. Used in quality control to track production process and detect defects or inefficiencies. Healthcare. Markov models help analyze patient pathways and treatment outcomes in medical research. Telecommunication, applied in network traffic analysis to optimize resource allocation and predict data flow. Weather forecasting using Markov process. Predict sunny days. Markov process helps forecast clear sunny weather condition, which is crucial for outdoor activities and planning. Forecasting rainy weather. By analyzing transition probabilities, the Markov process aids the predicting and preparing for rainy days and downpours. Partially cloudy predictions. Markov process models transitions between weather state, enabling accurate forecast of partially cloudy conditions. Predicting thunderstorms. Utilizing Markov chain, forecasters can anticipate and warn about the occurrence of thunderstorms and lightnings. Thank you.